find the radius and interval of convergence for this power series. So we have x minus a to the n. So this is the center. Okay, center of this power series is centered at 5. Center we denote a equals 5. Okay. Now we want to find the radius and the interval of convergence. For that, we take the limit of the ratio, and this is in fact the general term an. Okay, we find the following limit of n goes to infinity of a n plus 1 over a n. By the way, this power series always converges for x equals center, so x equals 5. This series converges for x equals 5, but we are interested in more. Then when x is not equal to 5, center, let's find this limit, which is same as limit n goes to infinity of a n plus 1. This is an, so a n plus 1 is just replace n by n plus 1. That's x minus 5 raised to n plus 1 over n plus 1. Okay, divided by, this is a n plus 1 divided by, let me write this way, an is x minus 5 to the n over n. Okay, let's work on this limit n goes to infinity of, okay, so let's change this division into multiplication, then this flips, and we can rewrite x minus 5 raised to n plus 1 as x minus 5 to the n times x minus 5 to the 1, which is not necessary. Like x raised to a plus b is same as x raised to a times x raised to b. Okay, over n plus 1, changing this division to multiplication, n over x minus 5 to the n. Now these two factors cancel, and this limit is concerned with n and n plus 1, so we can pull x minus 5 all the way outside with absolute value. So absolute value x minus 5, limit n goes to infinity of n over n plus 1, absolute value, but that is not needed because n and n plus 1 are always positive. And how about this limit? Okay, this is infinite limit that depends on the leading terms, n over n, which is 1, so this limit is 1, so we get x minus 5. And we know by the ratio test, this series converges when this limit is less than 1, and the series diverges when this is bigger than 1. Okay, by the ratio test, the power series, the given series, converges when if x minus 5 less than 1, and diverges when x minus 5 bigger than 1. That's why 1 is the radius of convergence. Okay, so we got the radius of convergence r is 1, and our center is 5, so basically we are in this situation now. 5, 1 to the right, 1 to the left, because the radius is 1, so 5 plus 1 6, 5 minus 1 4. Now we need to, for the interval of convergence, we need to test about 4 and 6. For sure the series converges on 4 to 6, but 4 may be included and or 6, so we need to test at the endpoints. So let me erase this part. So when x equals 4, the given series, original series becomes n from 1 through infinity. Let's go back up and check. When x equals 4, we get 4 minus 5, so negative 1 to the n over n. Okay, negative 1 to the n over n. Let me write in this way, negative 1 to the n over n, which is an alternating harmonic series. Okay, this is alternating harmonic series, or in general this is an alternating series, and it converges, because for alternating series all we have to show, for convergence all we have to show 1 over n decreases. That's true. 1 over 2, 1 over 3, 1 over 4 decreases, and when n goes to infinity, 1 over n goes to 0. Okay, this is alternating harmonic series, and this converges, which converges. That means the given power series includes 4, so we can put bracket. And now test for 6. When x equals 6, the given series, okay, the original series becomes, so let's go up and check. When x equals 6, 6 minus 1, 5, sorry, 6 minus 5, 1, 1 raised to n is 1, 1 over n. So we get n from 1 through infinity, 1 over n, which is a p series with p equals 1 diverges, or the famous harmonic series, this diverges. And this is alternating harmonic series, converges, which diverges. That means we cannot include 6 in the interval of convergence, so parenthesis. Thus the interval of convergence for the given power series, 4 included, center 5 all the way to 6, but 6 is not included.